to identify stereochemistry of an alkene, you need to compare the substituents that bond to the same carbon. For instance, on this carbon, there's a bromine and a chlorine bond to it. For this carbon, there is a methyl and a hydrogen bond to it. And by looking at that, you can identify their priority by numbering them based on the Kahn-Ingold Prelog priority rules. The same rule when we try to identify priority when we assign R and S for the chiral compound. So under that circumstances, a bromine would have higher molecular weight, atomic mass than chlorine, so bromine would have a higher priority than chlorine. And looking at the other side of the molecule, and carbon would have higher priority than hydrogen. Okay? Under that circumstances, and you could pretend to draw a line along the carbon-carbon double bond. Okay? If the high priority group are both on the same side, look at the step number 2, how to identify E and Z notation. If the two first priority substituents are together or on the same side of the double bond, it is a Z isomer. If the two first priority substituents are on the opposite sides of the double bond, it is an E isomer. For this case, and this is a Z isomer. Other examples including, if you look at the examples under 1A, and on the left carbon, you have bromine as your number 1 and chlorine as your number 2 priority. Comparing ethyl and methyl, and they both have carbon directly bonded to this sp2 hybrid carbon. What you're going to do is you're going to look for what bonded to these carbons. And for this carbon, there are 3 hydrogens bonded to it. For this carbon, there are 2 hydrogens and a carbon bonded to it. And obviously, and this ethyl group is of higher priority than the methyl group. Under that circumstances, if you draw a hypothetical line along your carbon-carbon double bond, you would have the two highest priority group on the opposite side of the double bond, so it is a E isomer. Okay, and follow the same rule, you could identify the stereochemistry of all of these alkenes.